Hello again, everybody. In this video today, we're going to be taking a look at the relationship between parallel and perpendicular lines as related to their slopes specifically. We already know what parallel and perpendicular lines are. We know kind of how they're related in a general sense, but in this video we're going to examine what we can tell about the slopes of parallel and perpendicular lines. So let's jump right in. First of all, a quick review. The slope of a line is a measurement about the line that is describing the steepness of the line, right? We talked about how, if you have a quick coordinate plane right here, a line that looks like this compared to a line that looks like this, well, this first line is less steep than the second line I drew. And so that would mean that their slopes are different. This would maybe have a slope that's further away from zero, that's greater in a way. Whereas this slope would be a little bit closer to zero because it's a little bit closer to being just a plain kind of flat or horizontal line. So the slope of a line describes the steepness of the line. Now, based on that fact, I think it would probably make sense to assume that if two lines are parallel, well, then what would we be able to assume about their slopes? If we look over here, I got a couple examples of a couple parallel lines. Now, on your notes, it's not in color, but you can see on my screen here, I got a green line and a blue line, right? And these are parallel lines. And so what can we just kind of assume? What educated guess can we make about the slopes of these two lines? And you look at that, remember slope is describing the steepness of a line. This line has a certain steepness, and it looks like this green line has the same steepness, right? If they weren't the same in terms of their steepness, if the green line was a little bit less steep, so it kind of came a little bit more like this, then eventually we can see it would intersect the blue line, and that doesn't happen when lines are parallel, right? Or if it was a little bit more steep, if the green line was a little bit more steep, so closer to being a vertical line, if it was up here like this somewhere, then we can see that somewhere down here below where the graph is showing, that would intersect the blue line right here. So in order for these lines to be parallel, the slopes or the steepness of those two lines, it would seem, would have to be the same, right? So if two lines are parallel, let's go ahead and assume that the slopes will be the same. We actually don't have to assume it. There is a way you can prove it. That's why this is going to be a theorem. But for now, we can kind of just get the general idea. We can kind of see why that would be true, right? Two non-vertical lines are parallel if and only if their slopes are equal, right? Now, perpendicular lines, those slopes will also actually be mathematically related, but we know that they're not going to be the same, right? In fact, they would be very different, because if two lines are perpendicular, so if I do a quick set of axes there, right? And let me go ahead and change color to make this a little bit more clear. If two lines are perpendicular, it means that one line looks something like that, whereas the other line, I'll go ahead and make it a different color, would look something like this. Now we know those are very different slopes. First of all, we know that one's positive and one's negative, right? This pink line looks to have a positive slope because if I was moving along the line from left to right, I'd be going up, and that means it's a positive slope. Whereas the turquoise line, if I was moving from the left part of the line to the right part of the line, I'd be going down, which means it has a negative slope. So we can say they're definitely not going to be the same. They're going to be pretty different. Well, how different exactly? In Theorem 13-4, we learned that two non-vertical lines will be perpendicular if and only if the product of their slopes is -1. Well, what does that mean exactly, right? The product of their slopes is -1. How does that happen? Well, first of all, product means we're going to multiply two things. And like we kind of already discovered just looking at this quick sketch, if you're going to multiply two things and get a negative answer, you know that one of them will be positive and one of them will be negative, right? Because a positive times a negative gives you a negative. So we know that the signs of those two lines will be opposite one another. Well, what else could we say in general? We know that slopes, let's just kind of look at a little example. We know that slopes are oftentimes given as fractions, right? We've talked in a previous video about how slope is the rise over the run, or it's the change in the y compared to the change in the x as you move from point to point on that line. So oftentimes the slopes of two lines will be given as a fraction. So let's say a certain line has a slope of, let's go 2/3. right? So we have a positive 2/3 slope of one line. Now, what would we multiply that by to end up with -1, right? 2/3 times what? So let's go ahead and make that, let's make that an x. 2/3 times x, or you know what? Since we usually use the letter m to represent slope, let's put an m there. 2/3 times what slope would give you -1? Now, if we took this little equation right here, we put the m over 1, we multiplied this together, that would end up with 2m over 3 equals -1, and I'm going to put that over 1, because what I'm going to do now is I'm going to do some cross multiplication. 2m times 1 is 2m, 3 times -1 is -3. So now to get the m by itself, I can see I just need to divide by 2, and I would have that that slope would have to be -3 over 2. Well, that's interesting, right? We knew it was going to be negative. We had already kind of decided that was going to be a negative slope. But look, the slope we started with was 2 over 3, and we figured out that the perpendicular line slope would be -3 over 2. And that is what always happens. This is one example, but it would always happen that way. If we picked out another number for the slope here and kind of set up a similar equation and solved it, we get the same thing. What do I mean? Well, if A, you know what, let's do this. Let's say if AB's slope, so the m of AB, the slope of line AB, is A over B, then the slope of, let's say, CD, so the m of CD, if AB and CD are perpendicular, it would be the opposite. So this one was positive, we'll make this one negative, and then we'll do the reciprocal, B over A. So if you wanted to jot yourself a note, what you might say is that perpendicular lines have slopes that are opposite reciprocals. Right? So this would be kind of the another way of saying that if two lines are perpendicular, their slopes will be -1. It means those two slopes will be opposite reciprocals of one another. So let's do a couple examples. In example 1 here, we're giving the slope of any line that's parallel to line AB and any line that would be perpendicular to line AB. So the first thing we need to do is we need to figure out, well, what is the slope of line AB? And we know we're going to do the change in y over the change in x. And we have to keep our order consistent here. So I'm going to do -6 minus 1 for the change in y. And I went with point A's y coordinate minus point B's y coordinate. So I needed to keep that pattern the same for the change in x. So I'll do 3 minus 2. Point A's x coordinate minus point B's x coordinate. Now simplifying this is going to give us -7 over 1, which is -7. So that's the slope of line AB. That tells us that any line parallel to line AB, the slope would be equal to -7. If any line that's perpendicular, if I'm looking at a line perpendicular to line AB, the slope will be the opposite reciprocal of that. Well, that's a -7 over 1. So the reciprocal would be 1 over 7, and since this one's negative, we would just keep this as a positive. So the perpendicular lines would have a slope of positive 1 over 7. Let's look at the next one. Let's figure out, again, the slope of line AB. Change in y, so 7 minus 7 over change in x, -4 minus 0. -4 minus 0. Now 7 minus 7 is going to give us a 0 on top, and -4 minus 0 is just going to still be -4. Now if we have 0 on top of a fraction, that comes out to be 0. So now our line AB has a slope of 0, so parallel to AB would have a slope of 0. But what about perpendicular to line AB? Well, what's the reciprocal of 0? Or if we took this 0 over -4 and we flipped it around, what would we end up with? Well, we'd put the -4 on top and the 0 on the bottom. But 0 on the bottom of a fraction, that's a big no-no in the math world, right? We can't divide by 0. And so what we can say about anything that's divided by 0 is that it's undefined. So if the line has a slope of 0, then the perpendicular line will have an undefined slope. And vice versa. If we find a line that has an undefined slope, then the perpendicular line would be 0. Now let's think about why this makes sense. Right? So quick sketch here. Quick sketch. A slope of 0 we've talked about before. A slope of 0 means that it is a horizontal line. Looks like that. Right? Now a line that's perpendicular to a horizontal line, what would it look like? It would be a vertical line, right? So that perpendicular line would be a vertical line. And what do we know about vertical lines? We know they have undefined slope. So it does make sense that these would kind of go in pairs when we're talking about perpendicular. 0 slope and undefined slope. That's the relationship between horizontal and perpendicular lines. Horizontal and vertical lines. Okay, one more example to take a look at. Example 2. Suppose a given quadrilateral has vertices at -2, 7, 3, 7, 6, 11, and 1, 11. Our job is to show that MNOP is a parallelogram, but not a rectangle. Well, if we think about the kind of the topic of this video, we know that parallelograms, they have opposite sides that are parallel, right? So let's first show that the opposite sides of MNOP are parallel. Let's find the slope of segment MN, of segment NO, of segment OP, and of segment PM, right? That would be the 4 sides of this parallelogram. So the slope of MN would be, again, change in y over change in x, so that would be 7 minus 7 over -2 minus 3, which is 0 over -5, which is 0. Slope of NO, that would be 7 minus 11 over 3 minus 6. 7 minus 11 is -4. 3 minus 6 is -3. So those two negatives cancel out, and that's a slope of 4/3. OP would be 11 minus 11 for the change in y's. 6 minus 1 for the change in x's. That's a 0 over 5, which is a 0 slope. And lastly, segment PM would have 11 minus 7 over 1 minus -2, which I'm just going to write as 1 plus 2, right? We know that 1 minus -2 is the same as 1 plus 2, so I just kind of skipped a little step here, wrote it as 1 plus 2. So now we have 11 minus 7, which is 4, over 1 plus 2, which is 3, which is a slope of 4/3. So you can see segment MN is parallel to segment OP. They both have a slope of 0. And segment NO is parallel to segment PM because they both have a slope of 4/3. So that's true. But why is it not a rectangle? Well, look at the consecutive sides, right? In a rectangle, consecutive sides will be perpendicular. MN is not perpendicular to NO. Because MN has a slope of 0 and O has a slope of 4/3, those are not opposite reciprocals. Or if you multiply those slopes together, you don't get -1. And so that means that MN is not perpendicular to NO. Therefore, MNOP is a parallelogram, but not a rectangle. Okay, folks, it looks like I am out of time, so I will see you in the next video when we talk about the midpoint formula. See you then.